So I'm going to change these back to good variable names. The reason you want to use good variable names is so that when you later or someone else is looking at your code, they can understand and they can make changes to it. So it makes sense to call this parameter radius and the return value area. That explains exactly, well, I shouldn't do that because that's the name of the function and I'm not sure that's going to work, so I'm just going to call it A. Then if I wanted to call it, print area of 10. Save it somewhere not in my Python directory structure. I'm going to call it fruit. I run it, and it should print out the area of the circle with radius 10. So temporary variables can make debugging these things easier. What is a temporary variable? It's when you have a variable that really all it does is hold a result and then is used to return that. Now, why might you want to do that? So maybe you could print it out or something. What if the area function wasn't working like I thought it should? And it's because I made a mistake in it. I only put in one asterisk there rather than two. If I had just this, return that, it might be harder to debug, or I would have to go and put some debugging code somewhere else in the program. But if I'm storing that result in a temporary variable and then returning that, then I could print it out in the meantime, print a area calculated as like that. And now when I run it, I have actually displayed that right there. And I would know, oh, that was wrong. That's not what I wanted it to do. That's where the area is. Now, this is a pretty simple formula to debug. We just look at it and go like that. But that is why you might want to do the calculation and then return it separately as a variable rather than to do what I did in my code example here, which is just to return the result of the calculation directly without storing it in a temporary variable. Here they have written an absolute value function, but we're going to write our own. I'm going to call it absol. And it's going to take a variable which I'm going to call x. Doesn't matter. If x is greater than 0, return x. Because if it's a positive value, then absolute function doesn't do anything to it. But if it's not greater than 0, then return the negative version of it. Now, there's two ways to make a number negative. What's one way? Yeah, multiply it by -1. That'll switch it. The other thing you could do is subtract 0, subtract it from 0, like that. So -1 times x, that would flip it to negative, or making 0 minus x would also make it negative. Now here I really could not think of a good reason to create a temporary variable to hold it. But we could. Here's our temporary variable. If x is greater than 0, a is equal to x. Else a is equal to 0 minus x. And then return a. Now we've used a temporary variable to hold the result of that for whatever reason. It actually added a line of code to it. It didn't make it any easier to read. I'm not sure that there was any good reason to do that, but we could print that out. We could test it out. Let's print out absol 2 different times. We're going to print out the absolute value of 3, which should be 3. And then we're going to print out the absolute value of -10, which should be +10. There we go. 3 add 10. So the absolute value function is working. When you're really getting desperate to figure out how your program is going, sometimes you'll wind up adding temporary print statements to it. Things like this. Print area, or area function. Just so you know where it is. And then print absol function. Just so you know where you are. You could even print that value that was being passed in, like that, so you could track it. You could pass in that value that was being passed in. Then if you wanted to, you could print what it returned. area function returned, and then say what it returned. The absol function returned, and we're going to say what it returned. So now as we run the program, it'll give us a roadmap. It'll show us breadcrumbs about how it ran. Okay, area function was called with 10. It returned 314. The absol function was called with 3, and it returned a 3. The absol function was called with negative 10, and it returned with a positive 10. All that's looking good. So these are just debug statements. Eventually, you'll want to go and comment them out. And it's kind of a drag to have to add a bunch of stuff that you then comment out later. But, you know, it can be very useful in the writing stage of your program to know how your program flow is going, because these are abstract things, you know. We're trying to figure out the flow of control, you know, and it's jumping all over the place. It first runs down here because this is the first non-indented code. As soon as it calls that, it runs up here and it executes these lines. Well, what if this function called this function, you know? What if we only wanted to print the absolute value of a positive radius? Excuse me, what if we only wanted to do a calculation if the radius was positive? I'm going to make my debug messages even a little bit fancier. So I'm going to preface them with the word debug, just to make blatantly clear that these are not supposed to be part of the output when we're done with the program. And then here I'm going, as part of my function, pass in the absolute value of the radius. So if they pass in a negative 10 as a radius, to calculate the area of a circle that's 10, it should work, but also it should give the same answer if we pass in a negative 10. I'm going to comment out these calls to the absolute value function right now. So right now we're only testing two things. We're testing the two calls to print. And here we go. Debug area called with 10. Absolute value called with 10. Absolute value function returned 10. Debug area function returned that. So that was the first call to the area function. And we can tell what all it did by our debug statements. Here we called it with a negative 10. Absolute value was called with a negative 10. But the absolute value returned a positive version of it. So we calculated our area with a positive 10 radius. And then that was returned. So we got the same answer both times. And in reality, if you think about it, how could you have a circle with a negative radius? So that kind of makes sense. I don't know. Anyways, so now we have added a whole bunch of debug statements to track it. One of the reasons we were able to track it so nicely is that we were storing the results of our calculations in temporary variables and then returning those temporary variables. You can have code that's known as dead code or unreachable code. That would be something like this. I'm going to write the short version of absolute value. I'm going to call it absol2. That did the return right away. If x is greater than 0, return x, else return 0 minus x. So there's my function, and now I'm going to add a print statement to it. Print absol2 is done. I think I'm adding a debug statement to it, but there's something wrong with this. What is wrong with this? What is wrong is that if we return here or we return here, there's absolutely no way to get there. That's called unreachable code. Every path out of the program has already hit a return statement, so we'll never get there. Some compilers complain and won't let the code even run with that kind of situation, and some won't. Python didn't care. It went ahead and ran. Let's change this calculation to absol2 and make sure it works just as well as it did. So when I call absol2 now, it's not going to print these debug statements because that was all for the absol function. Absol2 doesn't have any debug statements except for this one right here, which I'm claiming will never be reached. Let's prove that. And there we go. So even though it's calling that function, we never get that message. Why? Because if x was greater than 0, it returned there. If x was less than 0, it returned there. How could it get here? It can't. So that's dead code. You just have to kind of eyeball it. Some languages, like Java, won't even let you compile if there is any unreachable code in your functions. Python doesn't care nearly as much, so it's up to you to spot it. And why is it bad to have dead code? Just because it's confusing. You might put some extra statements in there thinking that they're all going to run. It's not like it stops the program from running, but it could lead to bad logic if you thought you could add more code here and it never actually happened. Sorry, I put that in the wrong one. This is the dead code example. So the print statement is dead code because it will never be reached. All pass through the function and in a return statement before this line of code is reached. All right, now this next thing works us through the creation of a formula that calculates the Pythagorean theorem. The first thing he did is just define a function that all it did was return 0, no matter what values you pass to it. The Pythagorean theorem takes in a if you have a graph of a right angle triangle, then you could pass in 2 points, and you could pass in 2 points, the x coordinates and the y coordinates, and it would calculate the angle of the hypotenuse. So the first thing he did was write a function, but it didn't do anything. Then he took a stab at figuring out what it was going to do. So he added 2 parts of the statement. It's still returning 0 now, so it's still not working right. But he ran it to make sure that it worked, make sure there were no syntax errors. Then he figured out that he needed to multiply those things together and add them. So he did that, but it's still returning 0. And then finally he gets 1/2 of that value. And he returns that. So it's not a bad idea to type a line of code or 2, save it, run it. Type a line of code or 2, save it, run it. At least that way you're making sure that you're not accumulating an entire page full of syntax errors that you're going to have to fix. Now, there can be a little bit of a drag if to run the program you have to input data in order to test it. But there's a way around that called unit testing. So debugging with print, I just showed you how to do that. It's inserting extra print statements. Now here it warns us, do not write chatterbox functions. A chatterbox function is a fruitful function that not only does its primary task, it also asks the user for input, or it prints the output. So you should not make your absolute value function ask the user for the number. You should not make your radius, your area function ask the user for the radius. Why? Because then you couldn't just take that code and give it to somebody else and them know that they could call the area function and have it work. It's bad programming to make your function that calculates a value also ask for that input. It should be passed in. So this is pretty good programming here, in as much as that one idea is concerned. It doesn't ask for the radius here. It depends on the programmer to pass in the radius, which we did down there. And if we want to ask for the radius, we can do that. We could add our own statement pretty easily. R is equal to the int version of the input. What is the radius? Okay, now we've handled collecting a radius. It's poor form for the area function to ask for that, to interrupt its flow in order to do that, but it's perfectly cool for us to do it. So, if Python had given us a max function, but in the middle of running, it asked us for a number, that would be pretty silly. Same with our version of absolute value. These fundamental calculation, these fruitful functions, should not be printing stuff. They should not be asking for stuff. The exception is if you're having to add debug statements in order to figure them out. It's okay for these things to be printing stuff out during the debug stage. But eventually we're going to want to go back in and either remove them or redline them by commenting them out, so that when we run it, it produces clean output. It's not all littered with all those print statements. Like this. Oopsie. I forgot to put a there we go. It says, what is the radius? I type in a value, and then it prints some stuff out. It did not litter the screen with all this chatty stuff. So after you're pretty sure your functions are working, it's a good idea to go and remove all the debug functions. But as an intermediate step, it's fine to go ahead and put them in. So if we were going to make some little bit of rules about what we've talked about so far, we would say fruitful functions perform a calculation and return a value. Some are built in, like max and ABS. When writing a fruitful function, it can be useful for debugging purposes to store the result in a temporary variable. And then return that value. For example, define calc, and whatever we're going to perform our calculation. Our result, A, I've been calling it, is equal to x plus x to the power of 2 minus x, whatever the dumb calculation is supposed to be. And then print x. No, not print x, return x. So in this case, A is our temporary variable. No, not return x, return A. Adding print statements to your debug function, to your functions, can make debugging easier. Now let's take the same code but add some print statements to it. So print calc called with, and then we pass in x, and then we print calc returned, and we print out the value that it's returning. And maybe we're going to put dbg or debug, the whole word or something like that. This way, while the program is running, we can see from the output what the function is called with and what it returns. This will help us understand program flow. Avoid writing chatterbox functions. A chatterbox function is one that should just perform a calculation, but is also asking for input or printing results. Yes, we added debug prints, which made them which made it a chatterbox function. But we will go back and comment that out and remove those debug print statements when we know it is working right. So you can call one function from within another. This ability is called composition. Here, for example, he's written a function called area2. The area2 function calculates the radius of something by calling the distance function. And then it calls the area function. So area2 is first calling distance to calculate the distance between 2 points using Pythagorean's theorem, and then it's calling area to calculate the surface area of the shape, whatever. So we have a function here that's calling another function. And that function could call another function. And that function could call another function. In my code, I had an example of that. I made the radius function call the absol function. So when we call area, it calls absol. That's called composition. Functions calling compositions. It's totally fair. It's totally legal. What is the radius? 100. I commented out my print statement, so I can't prove that it's going all the way into the absol function in order to run, but it does. We can see that. When we call area, the first thing it does is call absol, passing in the radius. We get the absolute value of that radius, and then we use that to perform our calculation. Boolean functions are functions that return a true or a false. Like if you wanted to write a function that would check to see if something was evenly divisible by 2. The way you check to see if something is evenly divisible by 2 is you modulus it by 2, and if it's got a remainder, you know it's not evenly divisible by 2. So I'm going to write a function called evenly divisible by 2. Now that's a horrible function name. It's hard to read. I'm going to tack on some underscores. And it's going to take a number and then it's going to do remainder is equal to x modulus 2. And if we have a remainder, if remainder is not equal to 0, or no, if remainder is equal to 0, that means it's an even number, right? So we return true, else we return false. In this language, we have to capitalize true and false for it to work. So down in my, I'm going to cut and paste this so that it's only right above main, so I don't have to scroll up and down as much. This is the main part of our code because it's the unindented part. There we go. Now we have our evenly divisible by 2. I'm going to call the input, which gets us the radius, and now I'm going to check to see if it's evenly divisible by 2 or not. So if I have to type this whole thing in because it's such a stupid function name, evenly divisible by 2, and I pass in that radius, then print that's an even number. Cool. Else print that's an odd number. Wow. Yeah. Stupid code, but it's showing the point. We're passing in a value. Some calculation is being performed. Based on the result of that calculation, we are returning either true or false. And since we have done that, we can use that as input for an if statement. Because under certain conditions, it'll return a true, and we would execute that. In other cases, it will return a false, and we will do that. I'm going to comment it out so that all we're doing is calling the area function one time. What is the radius? I'm going to kill this and run it again so the input appears at the top of the window. What is the radius? The radius is 8. That's an even number. Sure enough, it worked. Let's run it again. What is the radius? 11. That's an odd number. So that's working. Now in his code, he made a version where you pass in a second parameter that tells it, so that you could not only check to see whether it was evenly divisible by 2, but you could see if it was evenly divisible by 3 or 4 or 5 or whatever. So to do that, we would just add a parameter to our statement, to our function definition. It's no longer going to be evenly divisible by 2, it's just evenly divisible by. And so we take x modulus y. And if x modulus y has a remainder of 0, we know it's evenly divisible. So I could check to see if something was divisible by 10 by modifying our print statement. Our call here. Is the radius evenly divisible by 10? Then we would say that's a multiple of 10. Otherwise, we would say that's not a multiple of 10. Whatever. So we took this fruitful function, but we enhanced its functionality. Because here we had a number here, but why not allow that number to be passed in to make the function more flexible? Sometimes you might want to know if something was evenly divisible by 3 or 4 or 10 or 100 or something like that. So rather than hard coding that as a number 2 in there, we made that a variable. So we could pass in the variable that we want to check to see whether it's evenly divisible by 3 or 4 or 10 or whatever. And in this example call of it, we check to see if the input is evenly divisible by 10. If it is, we print a message. If not, we print another one. We can test it. I tend to do a test run after every change I make to the program just so that I don't accumulate a whole bunch of errors by not checking over and over. What is the radius? The radius is 20. That's a multiple of 10. It's good. Now let's see how different his function is than mine. Here's his. He didn't use a temporary variable. I stored mine in a variable called remainder. He didn't. Otherwise, it's very similar. Here he wrote an even shorter version of it. Okay, so let's follow the evolution of that. This is the long version of that function. This is the shorter version of it. I have to somehow give it a different name. I'm just going to call this, I don't know. Maybe I'll comment out the top one. The shorter version of it is to not use a temporary variable and then just to return this calculation right away. So if x modulus y is equal to 0, return true, else return false. So this is a shorter version. Why is it shorter? We didn't use a temporary variable. The shortest version of all would be just to return the value of this expression. Why would that work? Because that returns a true or false. If that didn't return a true or false, we wouldn't be able to stick it inside of an if statement. So to write if something return true, else return false, it's a waste of space. It's not a waste of time, but it just makes the program longer. And there's nothing wrong with writing it like this. I like writing it like this because it makes it crystal clear. And so I think that for beginning programmers is not a bad idea at all. However, you'll see a lot of more experienced programmers and the author of this website that we're using will do it like this. Here's the shortest possible version. Return that. You know, we don't really even have to comment these out thanks to so long version uses a temporary variable. Shorter version omits the temporary variable. And the shortest version simply returns the value of the expression rather than using if. Okay. I hope you can see why this is the same thing as this. Why this is the same thing as this. And the reason is that if you can do an if statement on it and return a true based on the value of that statement, then you could just return that statement right then and there. And by the way, I always put parentheses around my if statements, but you don't have to, and most Java books won't, including the demonstrations here in the on this website. I do it because in other languages it's required, and I think it makes the text look cleaner, but you don't have to. I'm going to go ahead and put it back in. Programming with style. Readability is very important. The easier you make your program to read, the easier it is to maintain it and to keep it working and to give it to somebody else and they'll understand it and be able to make improvements, which is really important if you're working in an environment with more than one person. You know, you may think, well, I don't need to take the time to do all this stuff because I'm the only programmer on it. But if you're working at a job with somebody else, or you're going to quit that job, you know, you need to write stuff that somebody else will be able to maintain. Here's one of his suggestions. Use 4 spaces instead of tabs. Meh, who cares? Limit line length to 78 characters. Well, that's reasonable. I would just not type more into a line than I could fit on the screen, you know. Because if you have a single line of code that goes all the way off the screen, you know, for whatever, that's probably too complicated of a line, and it should be broken up into several statements. So I'll buy that one. Don't make your statements too long. He suggests using camel case for classes. We haven't even talked about classes. And using lowercase with underscores for functions and variables. Now other languages have other things that they recommend. This author likes using lowercase with underscores for their functions and variables. And I did that here. Evenly divisible by. I made that all lowercase letters. But, well, anyways. Okay. Place your import statements at the top of the file. Keep your function definitions together. Just put all your function definitions up at the top of the file. Use 2 blank lines to separate function definitions from each other. I'm getting kind of bored reading these. Keep top-level statements together at the bottom of the program. Kind of an odd thing to say, but what makes them top-level statements? They're the first things that get run. So just like in our code here, I defined all of my functions up at the top of the code. You know, define, 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 and then finally I had a section called main, which actually ran those statements. And I put that at the bottom of the code. I didn't mix my definitions with my top-level code. This is called top-level code because it's the first code that's run. It's the least indented code. So, in short, just try to make your code easy to read. You know, put some extra return statements in there to separate things that, you know, like if you're writing a book, you hit character return and you create paragraphs. And sometimes you put space between the paragraphs to make them even easier to read. You know, so all this stuff, hitting extra character turns and stuff like that, is known as white space. And the more white space you put to your program within limits, the easier it is to read. Now, on the other hand, I'm typing code up here, and I want you to be able to follow along. So sometimes I will try to get as much code in as short space as possible. So quite often I am skipping adding white space. You know, so I would try to cram it all together like that so that I wouldn't have as much scrolling up and down. So sometimes when I'm up here, I'm not following, you know, any guidelines for good programming. Another guideline for it is you should not use single letter variable names, but again, to make things easy to type, you know, and for y'all, I tend to use single letter variable names, and if it's just a simple thing like this, that's fine. But if you're writing a payroll program, you know, use the word payroll, don't use the letter P. Use the word insurance, don't use the letter I. And especially if you have hundreds of lines of code. If you have hundreds of lines of code and all you're using your single letter variable names, it gets very difficult to figure out what's what. I want to get back to this idea, but I don't want to do it today. This is the idea of something called unit tests. I'll mention what a unit test is. A unit test is when you write code that tests your functions to make sure that they produce the correct values. For example, the absolute value function. I might want to test it to make absolutely sure that it works. No pun intended. So I might make a method called unit tests, and then it tests the absolute value function. A is equal to absol 10. Now what's the absolute value of 10? It's 10. So if A is equal to 10, then it worked. If A is not equal to 10, it didn't work, and I'm going to print an error message. Now this is not the best form of unit testing, but it's what I'm going to demonstrate right now. Now that's not a good enough test of the absolute value function. You know, typically, you know, you want to test all the ways out of it. There's two things it does. If it's greater than 0, it does one thing. If it's less than 0, it does something else. We might want to call it 3 times to give a really thorough test. We might call it with 0. The absolute values of 0 is 0. And then we might want to call it with a negative number. And we could make our print statements a little better. Absolute value of 10, return that. Absolute value of 0, return that. And absolute value of negative 10, return that. So even before my program started running, the very first thing I could do inside main would be to call unit tests. And it would perform all the tests that I've listed here. Right now there's only 3 of them. Now, our absolute value function is correct, so none of these are going to fail. So when it runs, it's not going to find any errors. It won't print anything. On the other hand, it won't run if I have invalid syntax, because I forgot to put colons. All right. That's because there's an error in my test, not because there's an error in the function. Absolute value of negative 10, return 10. That's actually a good statement, right? I wrote my test function wrong. What should I have been checking for here? Absolute value of negative 10 should return what? It should return a positive 10. So now I run it, and it's not going to give us that error message anymore. Maybe you don't like not seeing any error messages if it runs correct. Maybe you'd like for it to keep track if everything ran correctly. Well, you could do that. You could make a variable called errors and set it equal to 0. And each time you hit an error, add 1 to that value. I'm going to start adding spaces because this is getting a little bit hard to read. And then the last thing could be if errors is greater than 0 or equal to 0, we print out no errors found in unit tests. Okay, no errors found in unit tests. Now for something like the absolute value function, that's pretty trivial. But the function may be much more complex than that. And why do you do that? Because somebody may go in and change the function to do some other calculation. Like maybe somebody thinks that they know more about absolute values than we do, and they go here and they go, why are you comparing it to 0? It should be greater than 1. I'm going to change my test to not do 10, but to do 1, because I've changed the code. Sorry. I've written it in a way that there's a bug if you call it with the value of 1, and so I'm changing it to capture that code. I'm going to go back in and unmake that error so that it will run correctly at first. So to see if something needs to be returned positive or negative, you do compare it against 0. Now here's our unit test function. And it said no errors found in unit tests. That's good. I'm going to go and break my absolute value function by comparing the value to see if it's greater than 1. What's wrong with that? Well, if I pass in a 1, this test is going to fail, and it's going to return a negative 1, which is not what we want it to do. So now it runs and it says error, absolute value of 1, return negative 1. Right away, we know there's a problem. There's no reason to even continue testing this thing with that problem in there. And if you write a big program, it could have hundreds of functions. If you write a huge program, like you're working for the state and you're writing, stuff that, supports, millions of users or whatever, there could be thousands of function calls in it. If you have a unit test function that tests all of those functions, then anytime any of your programmers go and make a change to it, you could run that function and then make sure that it's all still at least, hanging together, that they haven't broken anything fundamental. There could still be something wrong with it. The logic of something might be wrong. But at least for everything that you've written into your unit test, you're sure that their change hasn't broken it. So somebody made that change. I ran my unit test. I see, oh, somebody's broken the absolute value function, and then I have to go, or I tell them to go and fix it. Now, this isn't all that illuminating when we just have one function that we're testing. But we didn't write a lot of functions that would lend themselves easily to testing. All we had is an area function in that one. Oh, we also had an evenly divisible one. Let's write a unit test for this one. We're going to test out evenly divisible by. Okay, so a is equal to evenly divisible, this is way too long of a variable, of a function name, divisible by, and I'm going to pass in 10, 2. In that case, a should equal true, right? Because 10 is evenly divisible by 2. So if a is not equal to true, then we would print out our error. Print evenly divisible by 2 returned. And then we would print out what it returned. And that's an error case, so we would add 1 to our errors. Now the function's written correctly, so that's not going to fail. And we would want to test it several different ways. That is supposed to be evenly divisible by true. Now we would by 2. Let's call it again in a way that would supposed to generate a false. What if I tried to see if 10 was evenly divisible by 3? Is it? No. So when we call evenly divisible by, is 10 evenly divisible by 3? What's it supposed to return there? Nobody's saying anything. Yeah, it has a fractional part. It's not evenly divisible, so a should be false. So we're going to make sure that it's false. If it's not false, we're going to print out. Alrighty, so since the code is written, I hope, correctly, these two unit tests are going to work just as well as the others did. My mistake was I always forget that you have to make capital T's and capital F's for true and false, not lowercase t and lowercase f's as in other languages. Alright, the only error we have is still that error with the absolute value function. I better go fix that. I'm going to scroll back up to the absolute value and correct my error. There it is. Now it will run and it should not produce any error output at all. No errors found in unit tests. Then let's induce an error into our evenly divisible by function. let's get these in the wrong order. Y modulus x. Now that doesn't make any sense at all, because if you're checking to see if 4 is evenly divisible by 2, you're not going to take the value of 2 and divide it by 4 and find its remainder. So this is wrong. And when I run it, ooh. Oh, that's because this wasn't the right version. I have 3 versions of the code in here. I need to comment out these versions so I don't make that mistake again. If you define a function more than once, it's only the last one that takes effect. Alrighty, let's try that again. I'm going to introduce a bug. I'm going to put these parameters in the wrong order so that if we're checking to see if 10 is evenly divisible by 2, we're actually dividing 2 by 10. That's wrong. That's a logic error. I run it, and it should tell me that evenly divisible by returned false. Oddly enough, the other one didn't. But that's okay. That's why you want to call your function several times with several different test values. And each time you find another test condition that causes your code to break, and then you have to fix it, go ahead and leave that in your unit test so that if that bug ever comes back again, then you're testing for that as well. Okay, since we're going to be uploading this code, I'm going to undo this error. There we go. Now it runs again. I've corrected the mistake. When I run it, no errors found in unit tests. So what is unit testing? Let's add a comment up to the top here. Unit testing is writing code that will test your functions, checking to see if they return the right values. For the given input. I'm not sure if we need to say much more of it. I gave 10 minutes of examples of it, but fundamentally, some years back, organizations had the view that their valuable asset was the program code and the documentation. Nowadays, organizations spend a large portion of their software budgets on crafting and preserving their tests. The reason for that is that once your code passes all of its tests, it's easier to keep the program working. If you're writing World of Warcraft or whatever, you can bet that they have some automated testing in there. That they test all the different pieces of it, as many different pieces of it via automated testing or not. And so then if a programmer goes in and they make a change to it, then the testing department can run their unit tests against it, and they'll flag that that it's got an error long before they publish it on the web and everybody's downloading them and having that error. All right, and then he showed a really fancy version of unit tests. Test at line 25 okay, test at line 26 failed, test at line 27 failed, test at 28 okay, test at 29 failed. Okay, so yeah, he wrote a different kind of unit test. We could do that one, but I already showed you one. I'm happy enough with it. Some things it's hard to create a unit test for though, right? Like our draw a circle. It doesn't return a value, so how could you check to see whether it worked or not? You can't. Unit testing is more for the kind of functions, it's better for fruitful functions. Drawing a circle is a void function because it doesn't return a value. But if it's a fruitful function, if it performs a calculation and returns that calculation, you can test it. Okay, let's look at this code right here and see if we can figure out which of these are true statements and which are false. Is 3% 4 equal to 0? Well, that means is 3 modulus 4 equal to 0. No, it's not. Because if you divide 4 into 3, it doesn't go cleanly. You get a remainder. You get a remainder of 3. So this one is false, and that one is true. What about 3 divided by 4 with a single slash? Is 3 divided by 4 equal to 0? That's not true, because it's not doing integer division. It's not doing floor division. It's not doing double slashes. That kind of gives the game away here. How about that one? Is that a true statement? That is true, because 3 divided by 4 does floor division. It does integer division, meaning it rounds it down if there's a fractional component. So instead of saying 0.25, it gets rounded all the way down to 0. So that one's true. That one is true. Let's see. 3 plus 4 times 2 is equal to 14. Well, what is 3 plus 4 times 2? What's the first thing to happen, the plus or the multiplication? Yeah, the multiplication. So 4 times 2 is 8. 8 plus 3 is 11. So this statement is false. How about 4 minus 2 plus 2? Looks like it would be true, but it's not. Why is that? Because addition and subtraction are at the same priority, so they just happen left to right. So 4 minus 2 is 2, plus 2 more is back to 4. And then lastly, test. Is the length of hello world equal to 13? Well, I'd have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's a true statement. And len is an example of a built-in function, one of the fruitful functions that Python gives us. All right, he put a lot of effort into trying to over the idea of unit tests. We're not going to spend that much time on it. All righty. I want to hit the next chapter, see what we're going to talk about. I think we may be done with the lecture today. And we have some homework due next week, so I don't feel too bad. I mean, hopefully it won't take you that long, but I'm not going to assign another one. So, okay. If y'all don't mind calling class a few minutes early, I talked myself out. So are there any questions over any homework we've done or anything like that? If not, I'll see y'all on Tuesday.